Recently, we have used AMOVLAB SU17 to make some development adaptations to meet the needs of indoor inspections. The drone operates in a confined indoor space using LiDAR for mapping, positioning, and obstacle avoidance. The drone takes off and lands automatically, FLIs mission waypoints, and completes specific tasks at designated waypoints. There are different obstacles between waypoints, and the drone needs to plan flight paths in real time for obstacle avoidance. First, import the digital twin map in STL format into the ground station. Load model. We can see a digital twin map like this. Then do waypoint planning on it. First, select the initial waypoint. After setting the coordinates, click Save. Then, according to the needs of the task, click Set waypoints number 2 to number 5 in turn. Start the flight mission after the waypoint setting is completed. OK. The drone takes off automatically from the takeoff and landing platform. The lower left corner is the grid map constructed by the LiDAR. The LiDAR SLAM algorithm is applied here. The lower right corner is the digital twin map of the current environment displayed on the ground station. The indoor modeling algorithm used here is. Here, drones are used for mapping, positioning, and obstacle avoidance using three-dimensional LiDAR. The QR code in the picture is not used to assist positioning. At this time, the drone has reached the second waypoint. The planned flight path can be seen in the map at the lower right corner, and the real-time flight path. Start the mission after arriving at the second waypoint, such as taking photos and videos. Obtain specific data based on actual project requirements. Stay for 10 seconds. Of course, the stay time can be adjusted according to requirements. The mission of the second waypoint is completed. The drone FLIs towards the third waypoint. You can see it on the map in the lower left corner. The red path is the path automatically planned by the drone. You can see in the twin map at the lower right corner. There are obstacles between waypoint 2 and waypoint 3. The drone needs to perform automatic obstacle avoidance during flight. Arrive at waypoint 3 to execute the task, and stay for 10 seconds. Task completed. Drone automatically plans the route. Start flying to the fourth waypoint. There is a pillar in the middle. There is some obstruction. The drone automatically avoids obstacles during flight. SU17 successfully arrived at waypoint 4. Stay for 10 seconds. Perform tasks such as taking photos and data acquisition. Task at waypoint 4 is completed. Start automatic route planning. You can see it in the grid map at the lower left corner. SU17 FLIs towards the fifth waypoint. Arrive at waypoint 5. Hover. Stay for 10 seconds. Perform some aerial photography tasks. Mission ended. Fly to the last waypoint, which is the starting coordinate point. We see the route planning in the lower left corner. Encountered an obstacle in the middle and performed obstacle avoidance. Gradually arrive at the takeoff position. Can be seen in this video. The stability and scalability demonstrated by the AMOVLAB SU17 drone in indoor inspection applications can be related to numerous indoor inspection application scenarios. If you have a need for indoor drone inspection, you are also welcome to contact us. At this time, the drone's gimbal automatically tilts downward to enter the visual guided landing mode. Here, a precise image-guided landing algorithm is used for visual guided landing alignment. The drone landed accurately on the parking platform. If there is a wireless charging module on the platform, it can perform automatic charging.